Maxwell's equation and plane electromagnetic waves. There are four Maxwell's equation. One, Gauss law for electricity. Surface integration of electric field over closed surface equal to enclosed charge by epsilon naught. The second one is Gauss law for magnetism. Surface integration of magnetic field over closed surface is always zero because of magnetic field always forms closed loop, no matter which is the source. Third one, Faraday's law for electromagnetic induction. Line integration of electric field over closed loop is minus d phi b by dt, rate of change of magnetic flux with negative sign, which gives EMF along the loop. And the fourth one, Ampere's circuital law. Line integration of magnetic field over closed loop is equal to mu naught sigma IC plus another term, Maxwell introduced this term, mu naught into E naught d phi by dt. This term is known as, this one is displacement current. Now we will derive E naught by B naught is C, and C is 1 upon root mu naught E naught. Faraday's law. Suppose this one is x axis, this one is y, and z, this one coming out of the plane of board, and light beam traveling in positive x direction. So electric field oscillate along y direction in xy plane, and magnetic field oscillates along z direction in xz plane. So this one is in xy plane. Ey is E naught sin omega t minus kx, Bz is B naught sin omega t minus kx. It's a traveling wave equation. Observe the figure. Now applying Faraday's law to the loop A, B, C, D. A is at x equal to x1, B is at x equal to x2. Integral E dot dl all over the loop A, B, C, D, A. So A to B integral E dot dl plus B to C E dot dl plus C to D E dot dl plus D to A E dot dl. This one is 0 because of electric in this direction and we are moving perpendicular to it. For this B to C, E at x2 into L, both are in the same direction. So E at x2 into L cos 0 is 1. Here also electric in this direction, we are moving this way. So it is 0, angle between them is pi by 2. And here we are moving this way, electric this way, so minus sign is there. Electric E at x1 into minus L. We know that electric field is E naught sin omega t minus kx. So E at x2 is replaced by E naught sin omega t minus kx2. This should be kx2. This one is also. Okay. Into L minus E naught sin omega t minus kx1 into L. So E naught L common, sin of omega t minus kx2 minus sin of omega t minus kx1. Now let's calculate the magnetic flux. We will consider a rectangular element having width dx at a distance of x unit, and d phi b is what? B dot A. So bx L dx. Length is L, this one, and width is dx. Angle between them is 0. So B naught sin omega t minus kx into L dx. But what about the magnetic flux all over the loop? So we have to consider integration. We have to take integration. Integral x1 to x2 d phi b. So B naught is constant. L is also constant. We know that sin omega t minus kx integration with respect to x minus cos omega t minus kx up into 1 by minus k, x multiple of x, and the limits are x1 to x2. So B naught minus plus B naught L by k. It is cos of omega t minus kx2 minus cos of omega t minus kx1. Now applying the rule, integral E dot dl is minus d phi b by dt to the loop. E dot dl is minus d phi by dt. D phi b by dt. We will take derivative of this term. Now this one. E naught, integral E dot dl is what? So integral E dot dl is E naught L sin omega t minus kx2 minus sin omega t minus kx1. This one we have replaced, and minus d phi b by dt. So minus B naught L by k into this one, derivative of this term. So minus sin omega t minus kx2 into omega minus sin omega t minus kx1 into omega. Minus plus minus, this one is also minus. So simplifying this, B naught L omega by k is sine of omega t minus kx2 minus sine of omega t minus kx1. But this one equal to this one, this term equal to this term, this cuts out. So we have E naught L equal to B naught L omega by k. L cut out. So E naught is B naught into omega by k. But we know that omega by k is the wave velocity because of V is lambda by t, multiplying both 2 pi lambda, 2 pi t. So rearrange term 2 pi by t upon 2 pi by lambda. It is omega, it is k. So omega by k is wave velocity. So E naught by V naught is omega by k. But here wave is light wave. So it is c, speed of light in vacuum. So E naught by V naught is c. Now Ampere's law. This one is x-axis, light beam traveling in positive direction, x direction. Y, this one is z. Electric will oscillate in y direction in xy plane, and magnet will oscillate in z direction in xz plane. Consider this rectangular loop E, F, G, H. It is at x equal to x1. It is at x equal to x2. The circulation of magnetic field B along the loop EFGS, line integration of B dot dl, E to F, F to G, G to H, H to E. For E to F, magnetic field and length both are in the same direction. So B at x1 into L into cos 0 is 1. Here magnetic field in this direction, length is this, perpendicular, so cos pi by 2 is 0. Here magnetic field in this direction and length is the angle between them is 180. So B at x2 into L into cos 180, so minus sign is there. Here also angle between them is pi by 2, so it is 0. So we will consider these two terms. B at x1 is B naught sin omega t minus kx1 into L. B at x2 is B naught sin omega t minus kx2 into L. Minus sign is here. So taking common B naught L, we have sin of omega t minus kx1 minus sin of omega t minus kx2. Now the electric flux through the same loop we have here. This one is B dot dl, this one. Now for the same loop, what about the electric flux? We know that electric flux is E dot dA. For this, we have taken small rectangular element having width dx at a distance of x. Area vector is in y direction and field is also in y direction. So angle between them is 0. So integral x1 to x2. We have to consider all such strips to find the total electric flux. So integral x1 to x2 E naught sin omega t minus kx into L dx, small area element. So taking E naught L common, and integration of sin of omega t minus kx is minus cos omega t minus kx by minus k x1 to x2, minus plus. So E naught L by k, again common, taking common k, we have cos of omega t minus x2 minus cos of omega t minus kx1. Now applying integral B dot dl is equal to mu naught E naught d phi by dt, because there is no conduction current. So we will use the second term. But integral B dot dl, this one, B naught L into sin of omega t minus kx1 minus sin of omega t minus kx2, this one, it is mu naught E naught into d phi by dt. Phi is this, so we have to take derivative of this term, but E naught L by k is constant, and derivative of this term is minus sin omega t minus kx2 into omega minus derivative of this with respect to t is minus sin omega t minus kx1 into omega. So taking common omega, mu naught E naught mu naught E naught, this is epsilon naught into E naught L by k. Omega is also common, sin omega t minus kx1 minus sin omega t minus kx2. But B dot dl is this. B dot dl is this. So this term and this term are equal. So cut out. So B naught L equal to mu naught E naught mu naught epsilon naught into E naught L cut out omega by k. Rearranging term 1 upon mu naught E naught is E naught by B naught into omega by k. But E naught by B naught we have derived already speed of light in vacuum. Omega by k is also c. So 1 upon mu naught E naught is c square. So c is 1 upon root mu naught E naught.